Hello and welcome back to the Ninox Learning Channel by Ninox. My name is Andy, I'll be your trainer today. And in this class, we're going to be looking at global functions and global variables. And by global, I'm talking about code snippets and code blocks and values that can be accessed from anywhere in a single database. Any table, any field, any formula. So let's get started. Now, the first thing to understand about global formulas, as I just mentioned, is they're available from anywhere in your database. Now, when we speak of local variables and local code, we are talking about values or constructs that only exist within a specific table. So what do we do when we want to create something once and use it over and over and over again? Well, first of all, we call that a global construct. And we're going to be talking about the two most important global constructs today, global functions and global values or global variables. We'll start with global functions, and they are exactly what they sound like. They are blocks of code that can be referenced from any table, from any field, from any formula, anywhere in the database where that global function has been created. So how do we create global functions? With our red wrench turned on in administrative mode, we go into the options screen. And about 3/4 of the way down, we see this field called Global Script Definitions. If we click on that, we see the formula editor that we're used to seeing, with one notable difference. There are no fields and there are no values in the parameters panel on the left. That is because the code that we write in this particular code editor is not associated with a specific table. Therefore, since it's not associated with a specific table, none of the fields or objects within a specific table would appear here in our panel. All we have is the code editor here in the body of the screen, this central section. We see two global functions, one called fcconvert and one called fclookup. We'll come back in a couple of moments and look at how these functions were created. But what I want to show you is, with these global functions created, we now can go into, for example, our conversion board, and we're going to be talking about foreign currency conversion today as our sample or example of global objects. We can go into the conversion board, and here we see 36 functions or 36 formulas. This is a 6x6 grid, which allows us to understand how US, Canadian, Australian dollars, euros, British pounds, and Japanese yen convert into each other. We have a simple field up here, a numeric field, and when we type in a number, which is a number of currency units, those currency units are converted to the 36 values that we see here. Reading the table is very easy. We find first what is called our base currency. Let's say our base currency is going to be the British pound. So now we have 250 British pounds. We then find the foreign currency into which we want to convert the British pounds. Let us say that is the Australian dollar. And then we find the intersection. Here's the British pound row, and we go all the way over to column 5, which is the Australian dollar column, and we see that 250 British pounds is equal to 449.37 Australian dollars. 250 British pounds is also equal to a little over $314, a little over 275 euros, 426.85 Canadian dollars, and 33,690 Japanese yen. So we find our base currency in the first column, we identify the foreign currency in the first row, and the intersection of our selected row and column is the converted value. If you look at each individual formula, you will see one simple line of code, beginning with the name of a function, FC convert, or foreign currency convert. We see one text field and a comma, a second text field and a comma, and the reference to a field in the table, the field named amount to convert. And you see this for every formula. When we want to convert British pounds to Canadian dollars, we see the same FC convert function being used. Convert British pounds here to Canadian dollars. If we want to convert Japanese yen to euros, we see FC convert, base Japanese yen, foreign is the euro, and the number, in this case of Japanese yen, that we wish to convert. So we have 36 formulas executing 36 pieces of math, but it's the same function every time. It's 250 of the base currency times the conversion factor that turns it into the foreign currency. So how did we manage to utilize this new function, FC convert, within the formula, or in this case, all 36 formula? Because we created a global function that we were able to call 36 times. Remember, a global function exists outside of any particular table. I could call the FC convert function from this table, this table, or that one, by simply plugging in the proper parameters and placing the proper call. Now, there are lots of functions built into Ninox. Think of functions as a machine. Pour in the raw materials, get out the finished good. The raw materials in a function machine are the parameters, and the finished good is the result of the transformation of those parameters. Global functions are exactly the same. They function the same way. Let's go back and look at our conversion board. We have a function. The function is called FC convert, or foreign currency conversion. It requires 3 parameters: a text parameter in the first position, a text parameter in the second position, and a numeric parameter in the third position. If any of these were to be wrong, for example, if the call was FC convert, but FC was not capitalized, we would get an error. Remember, when you call a function, whether it's a function built into Ninox or a global function, you always must recognize that function names are case sensitive. Similarly, what if the second parameter was actually a number? That's unacceptable, because this global function was built to expect 2 textual parameters followed by a numeric parameter. So putting the digits 250 in the second parameter position is not going to be acceptable to the function itself. So this is how we call a function. When calling a function, make sure you call it by the proper name. Make sure that your upper and lowercase formatting of that name is exactly correct. Make sure you are passing the exact number of parameters expected, and make sure you are passing the proper type of parameters that are expected. Whether the function is built by Ninox or built by us, these are the keys to a successful function call. Now, when it comes to global functions, these are functions we build ourselves. We see here how to call a global function. Let's now go see how we build a global function. Again, we must be in administrative mode, and we must be at the desktop of our database application. From the desktop, we select the Options tab and drill into Global Script Definitions. Some key things to keep in mind when creating a global function. Remember, I told you that the spelling and the upper/lower case of the name is mandatory. You got to spell it correctly. You've got to capitalize it correctly. Capital FC, capital C, lowercase onvert is the only successful way to call the FC convert or the foreign currency convert function. Every function must have a name, and every global function's name must be unique. You can have as many global functions as you want, but no two global functions can have the same name. Here we see two global functions, one called FC convert and the other called FC or foreign currency lookup. A function always begins with the keyword function. That is followed by the unique name of the function and an open or left parenthesis. Inside the parentheses, we name and indicate the type of parameters that this function will expect. We have our first parameter in this first function named base, and it is defined as a text parameter. Letters A through Z, special characters, or the digits 0 through 9 treated as text. The second parameter, called foreign currency, or lowercase FOR, uppercase C, lowercase URR, is also a text value. A comma separates each parameter. And finally, the third parameter, which we have named amount, is defined as a numeric parameter. This parameter will only accept values 0 up through 9 in any combination. You can only send numbers to the amount parameter because the amount parameter has been defined as a numeric parameter. Finally, the first line of the function ends with do, and the entire function ends with the keyword end. If you want to have multiple functions, simply put in your semicolon after the ending keyword, go to the next line, type the word function again to indicate the beginning of a new function, give it its unique name, paying attention to upper lowercase and spelling, define the parameters, and end that first line with the word do. Then define all of the transformative actions or activities you would like for Ninox to execute, and when you are done, end the global function. If I were to add a third function, a third global function to my list of global functions, I would simply add the semicolon at the end of line 37, go to line 38, open the keyword function, and this might be function 3. I would define the parameters. Maybe we have parameter 1, which is a text parameter. Parameter 2, which is a number parameter. Those would be the only two parameters. The word do. I build my machine or the transformative operations for this function, and when done, end it with end. You'll notice I have an expression expected warning in the top left-hand corner, and that's only because I have defined a function's beginning and defined a function's end, but I have not actually defined the function itself. So let's go ahead and do that now. I've preset the function, so I'm just going to go ahead and paste it in, and let's look at what our function does. It takes parameter 1, which we know to be a text variable, and it converts it to all uppercase. It then adds, hard-coded, a space and a left parenthesis. To that, it takes parameter 2, which is a numeric parameter, converts it to text, and then adds the right parenthesis. All of this entire concatenated string, is then styled with a red background. So we have a number of things happening. We're converting numbers to text. We are converting upper lowercase strings to all uppercase. We are concatenating variable values or parameters with hard-coded values, in this case the left and the right parenthesis, and we're taking the whole result and styling it onto a red background. You will notice that the global function is calling at least 3 Ninox functions: the styled function, the upper function, and the text function. So you can embed Ninox functions inside of global functions. You can embed global functions being called from within other global functions. So here we see this global function, this machine, which capitalizes everything in the first parameter, converts everything in the second parameter from numbers to text, embeds or encloses the second parameter in parentheses, makes one contiguous text string out of the 2 parameters, and then turns the whole text string red and passes it back. Notice our keywords. Function defines the beginning of a new function, the unique name, the keyword do, and at the very end, the keyword end. If a 4th global function were to be created, there would then be a semicolon and the keyword function, and then we would go into function number 4. We're not going to do that right now. Now that we have created a global function, let's go back to where a moment ago and see how we call the function. We will save it. And I'm now going to go back into my temporary table, that table 1, and we have a text field. We have a numeric field. In the text field, I'm going to type Smith Brothers Limited, and their customer code will be 5500. In the formula field, I want to show the name of the customer with the customer number in parentheses. I want the name to always be capitalized, and I want the whole thing to show up in red. So instead of writing that code over and over and over and over again, every time I want to do those 3 functions, I simply call my global function. And it looks like this. The call to the function, which requires a text field and a numeric field. And that's it. The spelling is correct. The name is correct. 2 parameters are expected. 2 parameters are delivered, and they're delivered at the proper type. The text field is the first parameter. Numeric field is the second parameter. And once I save my changes, we get our result. And now anything we type in here is going to be reflected down there. Let's say it's Jones and Company. We put in Jones and Company in 8574 as raw materials, and we get the name and customer code concatenated on a red background. So we see the build of the global function, we see the call to the global function. Now the next and last global construct that I want to speak of here today is the global value, or the global variable, if you will. In this case, we're still talking about a global construct. We are talking about something that exists within the entire database. The same way global functions can be called from any formula or any field in any table in a database, global values or global variables can be defined and utilized, or again, called from any function, any formula, any field or table, anywhere in the database. However, we approach this a little bit differently because the truth is, Ninox does not actually have anything explicitly called a global variable. And the workaround is really a combination of a global function giving us access to a global variable. I thought that would be good for this particular class. So let me show you what I mean. We have created a table called exchange rates. This table has 6 records, or 6 base currencies. And they are records, and this record number column is simply the ID of the record in the exchange rates table. So we have 6 rate conversions based on 6 base currencies: US dollar, euro, pound, Canadian and Australian dollar, and Japanese yen. The base currency is coded 1 through 6. Then we have 6 foreign currencies. Again, the US dollar, the euro, the pound, Canadian and Australian dollars, and the Japanese yen. 1, 2, 3, 4, 5, 6. So we have rows and columns that make up this foreign currency conversion grid. And at the intersection of each row or column is the conversion factor, or the global variable that we want to reference when going from a base currency to a foreign currency. For example, if I want to convert Canadian dollars as my base currency into British pounds, the cell in the grid that contains that global value is identified by the pair 4, 3. Row 4, which is my Canadian dollar base currency, column 1, 2, 3, which is the British pound. Row 4, column 3 is this value. And this value, 0.58550, is the conversion factor that converts Canadian dollars into British pounds. Now, each one of these variables exists in a unique cell. This is cell 1, 2, first row, second column. US dollar is the base currency, euro is the foreign currency. This is cell 6, 5. Row 6, Japanese yen is the base currency. Column 5, the Australian dollar is the foreign currency. These values exist in fields, and these fields exist in this one table called exchange rate. So we have this table of values, 36 as a matter of fact, that give us the conversion rate of every one of our 6 base currencies into any one of the other 5 foreign currencies. These values can now be treated as global values, or global variables. Now, since I might want to call a global value for foreign currency conversion from multiple places, multiple times in my financial or accounting database, I went ahead and created a global function that automatically takes a number of currency units, defines the base currency, looks up the correct foreign currency, translates the base currency into the foreign currency, and then returns the foreign currency value. That is this second global function that we see here called foreign currency lookup, or capital FCL, lowercase OOKUP, FC lookup. This global function, like the one before it, takes three variables or three parameters, but they are a little bit different this time. The base parameter is now a numeric value. The foreign currency parameter, also a numeric value. The amount, as it was before, a numeric value. Now it just so happens that I used the words base, foreign currency, and amount in two different global formulas. I do strongly recommend that you use unique names for your variables, especially if you are building multi-concurrent user or tenancy databases, where you have multiple people using it at the same time. One user might be calling one global function while a different user is calling a different function. Things could get a little bit confusing. This function will look up the base currency, look up the foreign currency, determine the proper conversion factor, and then, as we see here, multiply the conversion factor times the number of base currency units that were passed to the amount parameter. Let's see how it works. If we go into the lookup table, we have this little machine here. We define a number of currency units, and we define a base currency. We then select a foreign currency, and this number will be this many units of base currency, in this case 100 US dollars, translated or converted into Japanese yen. If I wanted to translate 10,701 Japanese yen into the US dollar, it would go the other way. With rounding involved, it came up to almost $100. If I wanted to convert 500 British pounds into Japanese yen, I would get 67,380 Japanese yen. This formula is simply calling the lookup function. Here is the call to FC lookup. We're passing one numeric value, a second numeric value, and a third numeric value. Now these numeric values may look a little bit strange. This is where it's important to think about the user interface or the user experience. So what we've done here is we've created two choice fields, one called base currency, one called foreign currency. They both have the same 6 choice values, and we see them here. The choice values are numerically defined by Ninox. British pound is defined as choice 3. Japanese yen, choice 6. So what's happening here is when I take and select, for example, Australian dollar as my base currency, I've selected the 5th choice. This function takes the base currency choice field and converts it to the number. What number in this case? The number 5, because I chose the 5th choice. So this is the number that I want to pass to identify my base currency. This is the number that I want to pass to identify my foreign currency. And this is simply the numeric value of this choice field. So we pass the base currency number as the first parameter, the foreign currency number as the second parameter, and the number of base currency units as the third parameter. We call FC lookup as our machine. Let's look at the machine real quickly. We go here. The machine receives a numeric code for base, a numeric code for foreign, and a number of base currency units. The first thing it does is it goes into the exchange rates table and finds the record where the ID is equal to the base currency number. If I passed the value 5, record 5 is Australian dollars. Then we initialize a variable called conversion factor, and we just initialize it to 1. And then we do a switch based on the foreign currency. The foreign currency will be a number between 1 and 6. If it is the number 1, the currency is the US dollar. If it is the number 4, it's the Canadian dollar. If it's the number 2, the foreign currency is euro. We already know our base currency, we selected it here. The foreign currency is the particular field in that base currency record, that record called X base record. So X base record dot US dollar is the US dollar conversion factor for the base currency that is the record number 1, which happens to be the US dollar. If we want to convert Australian dollars to Japanese yen, Australian dollars is base currency record 5. So we would pass the number 5. We would select the exchange rate record where the record ID is 5. So now the X base currency record is Australian dollars. We then would look for field 6 for our foreign currency because we pass the number 6 to the second parameter. When the foreign currency equals 6, the foreign currency in the base record is the Japanese yen. So now, by passing 5 and 6 and a number of currency units, this many base units, which in this case is Australian dollars, will be converted by multiplying the amount of base currency units by the conversion factor, which in this case is the conversion factor for Japanese yen from Australian dollars. This machine is a global function that I can call from any table, any field, any variable, function, or formula anywhere in this database. And this global function will look up in this table of exchange rates the exact rate in my grid of 36 based on the numeric code for base and the numeric code for foreign. So that turns this exchange rates table into a table of global values or global variables. I can look up a particular cell in my grid by simply referring to the row number, which is my base currency here, and the column name, which is the foreign currency, or I can place a call. I can place a call that says, here's my numeric code for base, here's my numeric code for foreign, this is how many base units to convert, send back the conversion. In this case, 1 Australian dollar is equal to 74.96 Japanese yen, or 1 euro is equal to 0.91 British pounds sterling. Here we have a global function looking up a global variable, returning the value to this field, specifically to this formula function, but this could be any field, any formula, any function in any table, anywhere in our foreign currency converter database. Because now we have a table of global values and we have a group of global machines or global formulas that transform base currency into foreign currency. If you'd like to copy and paste this or either one of these global functions into your database, simply go to www.nioxus.com, download the foreign currency conversion template or the foreign currency conversion global function, copy and paste, because those templates and functions are unlocked, copy and paste the function you want, paste it right into the Options tab, Global Script Definitions field, and you will be up and running with your own foreign currency conversion system. The other thing you can do is if you log into nioxis.com and log in to the member portal, from your member portal, you can go into the Global Functions menu and see all of the global functions that we have available for you to copy and paste. There are global functions to add any one of 37 different global currency symbols to your numeric values. Here's a global function that converts Fahrenheit to centigrade, converts names to initials, or converts a person's name into a person's initials or first name last, or any way you want to represent a first, middle, and last name. These global functions we've built for you are machines that you can literally select, right-click, and copy, and paste them right into your database. And with each global function, we have user instructions that help you understand how the function gets used. So for example, this particular function can turn a first name, a last name, and a middle name into any one of these 10 representations simply by passing the proper parameters, which in this case is a first name, a middle name, a last name, and the mode. The mode is 1 through 10, and the mode you pass will determine the result you get. So don't forget to check out all the global functions as well as the foreign currency conversion template here at your Nioxis member portal. And that's it for today. We've talked about two very important global constructs. The global function, again, think of it as that machine. Parameter, raw materials go in, and finished goods or transformed content comes out. And we talked about the global variable or the global value. Not a construct built into Ninox, but by creating a table, defining values within that table, or defining values within the fields or formulas of that table, and then referring to those fields, whether they are data fields or formula fields. By referring to them using either the select feature or a global function, you now have all of the capabilities of global variables right inside your Ninox database solution. Thank you so much for joining me today. I hope you enjoyed our little dive into global constructs, and I hope you'll come back and join me again next week here at the Nioxis Corporation Ninox Learning Channel. I enjoyed working with you. I hope you enjoyed learning with me, and I hope I see you in the classroom next week. Bye-bye, everybody.